Hello everyone, I'm forecaster Jack Sillin here to discuss the severe weather setup for Tuesday, May 1st, 2018. Here we have a look at GOES East water vapor satellite imagery here at WEATHER.US. And we can see a large area of counterclockwise circulation, counterclockwise winds moving around an upper level low pressure located across parts of the Rocky Mountains. And it's the southwesterly winds out ahead of that trough, as well as the rising motion that exists in front of the trough, that's going to create conditions generally supportive of severe thunderstorm activity across parts of the plains today. So in the upper levels, we have, again, this setup ahead of this upper level low that's generally favorable for severe weather conditions this afternoon. At the low levels, we have another feature that we can see here on our dew point observations map, and this is known as a dry line. So you can see dew points very high, indicating moist air moving in off the Gulf of Mexico through Texas and up into parts of the southern plains. Over New Mexico and southern Colorado, on the other hand, you have very low dew points, so bone-dry desert air, and the delineation between these two air masses is very sharp. So you go from very moist air dew points in the 60s down to dew points right near zero in just a matter of a few miles. So this dry line will shift east as the sun comes up this morning, and will be set up from southern Kansas through the Oklahoma and Texas panhandles by this afternoon. And that's where we are going to watch for some potential severe weather activity as the afternoon and evening wears on. To take a closer look at some of the other factors driving this severe weather potential, including what kinds of threats we might be looking for from severe storms today, we're going to head on over to our Ecmwf Thunderstorm Composite map. So this shows all the ingredients that we are going to need to put some severe thunderstorms together this afternoon and evening. We have instability shaded here. This is thunderstorm fuel, if you will, and the more fuel there is, the stronger the thunderstorms can get. Cape values range from 1,000 to 2,000 joules per kilogram, so that is very supportive. Anything over 1,000 joules per kilogram is a setup where you can get some pretty active severe weather. In terms of winds, we see that we have plenty of wind shear, so that's another important ingredient for severe thunderstorm formation. And wind shear is the change in wind speed and or direction with height. So we have both changing wind speeds and changing wind directions with height this afternoon, and that is going to be favorable for severe weather. So if you take a look at this data point here in central Kansas, we have kind of weak southeasterly winds at the surface. That's the black arrow. We have pretty strong southerly winds in the lower levels of the atmosphere, so that's about 5,000 feet, that red arrow here. Then we have very strong west-southwesterly winds in the middle and upper levels of the atmosphere. So we're getting both strengthening winds with height and changing winds with height, and those two conditions will be favorable for severe weather. And notice that this wind shear overlaps with the area of instability. So we have all the ingredients kind of coming together. The final ingredient that we need is a trigger mechanism of some sort, and that will be the dry line, which we can see here is kind of the western delineation of this area of high instability. And thunderstorms will be able to form along that dry line, as well as along a frontal boundary that extends through northern parts of Kansas into southeastern Nebraska and Iowa. So there are plenty of ways for thunderstorms to get going in this area this afternoon. There's plenty of wind shear, and there's plenty of instability. So parts of Kansas and Nebraska definitely should expect severe weather to occur this afternoon. Farther south in parts of Texas, you see we have some instability, we have a little bit of wind shear, but we're not expecting much, if any, thunderstorm activity. And to show you why, I'm going to head into our parameters menu here on the left side of the image, and I'm going to scroll down until I get to 700 millibars, so about 10,000 feet temperature. Now you can see that there are some different temperature setups here at 700 millibars, quite a bit different in Kansas compared to Texas. So why is this important? Well, thunderstorms need a vertical temperature gradient to sustain themselves, and a vertical temperature gradient basically is how fast can temperatures cool off as you head up in the atmosphere. So There are always going to be some fairly warm temperatures kind of across this region today at the surface. So this gradient is kind of modulated by how fast temperatures cool off as you go up into the lower and middle parts of the atmosphere. Now up here in Kansas, where 700 millibar temps are between 5 and 8 degrees Celsius, you have a substantial, not an extreme temperature gradient, but it's there. Compared to the 700 millibar temperatures of 10 to 12 degrees Celsius down here in Texas. So that's a very low, a very weak gradient, if you will. And that is going to prevent storms from really even developing at all south of the Red River Valley. So most of our severe thunderstorm activity is going to be focused where the cooler mid-level temperatures are, and that is in parts of Kansas and Nebraska. To take a quick look at what kinds of threats we might be expecting from severe weather today, we're going to actually head right back to the thunderstorm composite map because it's these wind vectors that can really tell us a lot about the potential setup. So we are going to look for two things. We're going to look for our surface winds, what we call backed. And backed means out of the southeast or with an easterly component. And the answer is yes. So you can see they're not southwesterly winds at the surface here in our area of interest. These winds are south-southeasterly. And what that does is it creates enhanced rotation in the low levels of the atmosphere. So in that enhanced rotation will help to support a tornado threat, especially across parts of central Kansas, central and southern Kansas here as we move through the evening. The other thing we're going to look for is what's called the shear vector pointed parallel or perpendicular to the boundaries that storms are going to form on. So we have two boundaries. We have a stalled frontal boundary that kind of extends from southwest to northeast here across parts of northern Kansas into southern Nebraska and Iowa. And then we have the dry line, which is oriented from north to south from Kansas, or parts of central Kansas through southern Kansas and into the Texas and Oklahoma panhandles. And the shear vector is basically, if you take the average or kind of add up the sum of these vectors in the low to mid levels, and what you get is basically southwesterly shear vector today. So that shear vector is going to be oriented parallel to the frontal boundary in this region and perpendicular to the boundary of initiation, as it's known, down in this area. So why is that important? Well, when the shear vector is pointed parallel to the boundary, you are going to favor linear storm modes. So kind of think lines and clusters of storms as opposed to more discrete cells. And those lines of storms are going to be better at producing damaging winds than tornadoes. Although, of course, tornadoes cannot be ruled out. The environment is fairly favorable with that low-level rotation we talked about earlier. But in general, the lines of storms forecast to develop in this area are going to be less of a tornado threat than the more discrete cells that you're going to find down in this area. Remember that even these cells are going to produce damaging winds in addition to the tornado threat, and any cell that develops today, whether it be as a standalone entity down here or as a part of a line or cluster up here, will be a threat for, or will pose a threat of heavy rain, lightning, and large hail. So to take a quick look at how the setup will evolve throughout the day, we're just going to take a look at some of our weathermodel.com simulated radar products. So again, don't take anything here too literally. It's just meant to be a general overview. Fairly quiet this morning as the sun comes out and we have to destabilize the atmosphere, kind of charge it up. Storms will develop right around 5 p.m. Eastern Time, 4 p.m. Central rather, and move to the east and northeast through the rest of the evening. You can see what I'm talking about in terms of the lines of storms up here compared to the discrete cells down here. That's as a result of the shear vector dynamics I was talking about earlier. And again, this is the area of greatest tornado threat with damaging winds being a threat farther to the north and east. Storms will weaken as they kind of congeal and move to the east overnight. More severe weather expected tomorrow. I will have another video on that either tonight or tomorrow morning, so stay tuned. Thanks for watching.